Hi, welcome to this example for MapReduce programming. We're going to use a small demonstration here to show how MapReduce will work. The input to this program is a small file. We're using a small file because we of course want to run it as quickly as possible. The input to this MapReduce program is a file that has data like this. It has data about soccer games. So every line that you have is about one soccer game. So in each of the line you see there is a game ID, date on which the game happened, the total number of goals in a game, and then who actually scored the goal. So there are on 23/5/15 there are there is a match that happened. There were 3 goals scored, and then Ben scored 2 goals and Tom scored 1 goal. So each line is about a game. Now the goal of the entire MapReduce program is to find the total number of goals scored by player. So how many goals did each of the player got it. So obviously the moment you look at by player, then player obviously becomes the key on which you want to design your MapReduce program. So how does this MapReduce program flow will look like? Let us go and look at the flow here. So the same file which had information about, let us say, the 6 games, let us assume that it is split into 3 splits, each split having 2 lines. Of course, it is going to have a lot more lines than that, but for simplicity reasons here, we're just focusing on only 2 lines. 2 lines per node. So there are 2 lines here, there are 2 lines here, there are 2 lines here. And then the map program is going to take this as an input. These 2 lines as an input is going to go line by line. What it is going to do is it is going to write each line of code and it's going to output a key and a value. So it's going to go and read this particular line that you see here, and then it is going to output Ben 2 and Tom 1. Then it is going to read this line and just going to be outputting Mike 1. So it's just going to reading this, and this is the output: Ben, 2, Tom, 1, Mike, 1. And here in node 2, as you can see, it is reading each line and outputting the person and the number of goals they scored in that match. So you will see that the same key is repeated again. So Ben gets 1 here, Ben gets 1 here, because Ben scored 1 goal in this 19th game. He scored again in the 20th game. So it's just going to be reading this file and outputting the player and the number of goals they scored. And the same happens in node 3. So when the merge and sort happens, what happens is these 3 sets of lines are then merged together. And as you can see, the same key is repeated multiple times. Like Ben is occurring here, here, and here. Mike is occurring here, here, and there are 4 places Mike is occurring. The key is consolidated. So you take the key and all the values for the key then becomes the list of values. Let's say Ben here, Ben is 2 here, Ben is 1 here, Ben is 1 here. So Ben, then the list of values become 2, 1, 1. So you take the key and collect all the values we find for this particular key from all the output of this map programs and consolidate it like this. So you have keys and you have a list of values for the key. So this is done for you by Hadoop. Now once this happens, then you pass this as an input to the reduce program. The reduce program is going to get 1 line at a time. So Ben is going to be coming first, and then Mike, and then Tom. And for each line, the reduce program can do anything we want. But given that the goal of this program is to compute total number of goals, it is going to just take each key. It is going to go look at the list of values for that key and then just add it up and then output the final result. So it's just going to be taking the key and the list of values. It's going to just add up the list of values and output the final total. So that is all it is going to be doing. It's a very simple, straightforward MapReduce program, but it's as you can see, a 2-step program that is happening. So to look at more about how this code looks like, let us go to this thing here, where you'll be looking at the Java code. So I've written just one Java file, exercise.java, inside which I built 2 classes. There is one class for the mapper and the other class for reducer. Of course, you could have written them in 2 different files, but I just, for simplicity sake, I just picked up just one file here. The first class you see here is the class. It has 2 classes inside. There is a public static class called soccer score mapper. So the soccer score mapper, it extends a regular mapper class that is a part of the Hadoop Java distribution. It is a standard class that every mapper program has to extend. So that is a standard rule you have to follow. And then inside this, there are 2 variables that define you see that score is an integer. It uses a type called intwritable. Intwritable means it is a data type that is given to you by Hadoop, and you have to use that if you are to be doing if you are to be outputting key value pairs. You have to be using these data types, not your regular Java data types. So intwritable is you are to use for integers, and there is another data type called text that we use for text. Then here comes the map program. This is a standard definition of how a map program will look like. So you're basically overriding the map function in the base class. So there's a map function, and the main thing you see is this text value. There are other things that are also passed to your little advanced stuff. We are not going to focus on them. So the map program gets as input the text value. So every line in the file is going to come to you once. So we saw that the input file had actually 6 lines. So this map function is going to be called once every line. Then what the MapReduce program does with the line depends on your own specific situation. So here we are just going to be taking the value and then splitting that by comma. So you see the file here. So this line of code, first you have to split by comma to get the individual items out. So you're first going to be splitting it by comma, and then what you're going to be doing is you're just going to be iterating it over the value. So you're splitting it by comma to get the key values, then you just iterate it by each of the key values. And each of the key values that is coming out, you again split it by the equal to sign. So you can get the key and value. So you can get key and value like this out of this one. Then you just make a test, and this is of course a rude way of eliminating data. So I'm just going to be ignoring the values if they start if the key is game or date or goal. So if you go back to the scorecard here, if it is game or date or goals, I'm just going to ignore them. A crude way of ignoring it, but it's a simple example, so I'm just ignoring them. If it is not any of these, then it is going to be the player and the score. So that case, what I'm going to be doing is I'm going to do player.set the value array of 0. So that is the name of the player is set to player, and then again the value array of 1 I'm converting to an integer and then setting a score. Now when you're doing all these value conversions, you might hit upon issues with incorrect values or cannot convert to integer and stuff like that. We're just ignoring all of that for the simplicity sake here. So the score is set to the value to the score, and the player is set to the thing, and then you finally say context.write. This is where you are outputting the name value pair or key value pair. Context.write the player and the score. So this is the output you get out of this name value pair. So going back here, this is the output that you're going to be getting out of the map function. Now moving on to the reduce function. So again, another stack class called soccer score reducer. It extends a regular class, a base class called reducer that comes as a part of your Hadoop distribution. And there is a function called reduce that you have to override. So this reduce function, as you can see, gets as input a text key. So it gets a key as a text and an iterable list of values. So this gets a list of values, so keys and list of values and a context. And then it is up to you to do what you want with these values. In this case, all we are going to be doing is finding the total of these values. So we just initialize this value total, then iterate over individual values. Iterate over these individual values, and then as the values come up, keep adding them to the total. That's all you would just do. Iterate over the values and then keep adding them to the total. And then finally, once you have iterated and found the total scores for the player, then do a context.write the key and the values. Now this is going to be given the player and the list of values for the player. So going back to the example, the reduce function is going to be taking this kind of an input, when 2, 1, 1 and stuff like that, and output the total value. Okay, and then there is the regular job configuration. This is the overall job configuration which you do is you have this public static void main. In the main program, you create this configuration object and the job object, and then you basically do a set of settings. Like you set, first of all, what is my jar? The jar is exercise.class. Then you set your mapper. What is my mapper? This is the soccer score mapper. What is my reducer? It is soccer score reducer. What is my output key class? What is the class of the key? And what is the class of the value? The key is going to be text. The value is going to be integer. So we know that the text is basically representing the player name, integer is the actual score. Then you're going to be adding the input path and the output path. Where is the input data going to be coming from and where is the output going to be going to? And for that, I'm going to be using my command line arguments. When I call my program, I'll be passing the input directory where my data is sitting as a part of the input path, and the output is again passed as a command line value. Then I simply do a system.exit job.wait for completion. Now this example file is available for you as a part of the resource bundle. So are all the shell scripts associated with this. So this is your overall class file that you would be using. And once you have that, how do you compile this program? For compiling, again, you use this command. This is a shell script that we built for compilation purposes. Make sure in the class path, this particular the jar file exists. This is all the libraries that are required for writing a Java MapReduce program. And then you say the exercise Java, which is my input file. This is going to create you a bunch of class files as an output for you. Then you do this jar cvr to create this exercise.jar file. Basically, zip up all the class files that you get into a jar file using this command. So this is your compilation, compile.sh command. Then how do you execute it? So executing, again, this is the things you have to do. You first add something to the class path. For the class path, you're going to be adding these few files that are available as a part of your Hadoop distribution. So given that you're using a Cloudera VM, these files are already available to you in these places. The input data for this example is sitting actually in this directory called data. So we begin the exec.sh by just outputting what is sitting as an input for your particular data. So Hadoop fs -cat data/star, which means it is going to just output your input. Then it is going to just go and start the MapReduce program. Before starting the MapReduce program, I'm just going to delete the output directory if it already exists. Again, another command, Hadoop fs command rm-r is going to be delete the output directory if it already exists. Then this is how we execute the MapReduce program. I'm just going to be calling Hadoop. Then I'm going to be calling setting a parameter called jar, saying the input file is going to be a jar file. And for that, the exercise.jar file that I built is passed as a parameter. And then the next parameter is what class within the exercise.jar contains the main class for me, that is the exercise class. And what are the inputs to the exercise class? This first input is the input directory, which is the data directory. And the second is the output directory, which is called output. So this command is go and execute the entire MapReduce program for you. And finally, when it is complete, I'm just going to output this MapReduce output, And then finally, I'm going to be just doing a cat of the output directory. There is a thing called path -r-r-000. This is how the output directory is created. It creates these files in this particular name format. Basically, the files are split as I think 1024 MB or something like that for easy management purposes and easy splitting purposes. And then you can just cat the files using this command pretty simply. So once I have all the shell scripts, I'm having Windows to do all of these, create all of these, but I'm going to be executing it on Unix. So let's go to my VM. And the VM, I have these examples copied over in this particular directory. You can copy them using, scp command, because once you install a VM, it will have its own IP address. You can find out by using ifconfig. Ifconfig will tell you what is the internet address of this particular VM. So you can connect to this from your local box and then, copy over the files and do things like that. So always remember to do a couple of things when you copy files from DOS to Unix. Run this DOS to Unix command so that it takes care of doing some formatting stuff. Like there is usually a control M character that you will see showing up anytime you copy a file from Windows to Unix. Then you also want to give execution permissions for your shell scripts using a chmod command. Both are Unix commands, you run it. Now you can just do a compile.sh to compile the whole thing. The compilation is done, and it is actually packaged into a jar file for you, the exercise.jar. Then you want to execute it by doing the execute.sh. The input file, this is the scorecards.csv files have already been copied to the data directory using the copy from local command. Pretty simple, straightforward command. And then you're just going to be executing it. exec.sh. So it's first going to print you the input data that is there. It prints the input files. It is starting the MapReduce program. When it starts the MapReduce program, it is going to give you a lot of information. Some of the things you want to notice is, it's connecting to the resource manager. The number of splits it has identified is only identified one split because the file is pretty small. It also gives you a URL here to track the job MapReduce program. So if you click on the URL, you'll basically see a web browser opening up saying what is the status of the program. But of course, you can watch the status even in this command. It tells you what it is doing. So it has started the MapReduce. It says map 0% complete, reduce 0% complete. And as it progresses, it will keep giving you the progress here. So map is now 100% done. It's now waiting for the reduce to complete. While we wait for the reduce, this one typically takes some time. Even if it's a small file, you will see that takes some time to execute. That's how Hadoop works. For small files, it takes some time, but large files, its scaling is fairly linear. It is complete now, and then it outputs the output directory as per the command we had in the shell script. You see the output is Ben4, Mike4, and Tom4. So this is exactly how a MapReduce program works. So we built a MapReduce program, a map function, a reduce function. We compiled it, and then we executed it, and the output is currently available to you in this output directory, which we just outputted basically using the command. So once again, please go and review the files. These files are available in your resource folder and in your resource bundle. So please review the files and get to know more about how these files work. We are not concentrating a lot. This is just a simple example for MapReduce to give you an overview of how MapReduce works. I hope this lecture has been pretty useful to you. Thanks.